Have you ever been playing a game and just marveled at how a character seems to think for itself, how it knows exactly when to run, jump, or duck behind cover? Well, it's not magic. It's actually a really elegant piece of logic working behind the scenes. And today, we're going to pop the hood and take a look at that digital brain, the hierarchical state machine. So here's the game plan. We'll start with the huge problem that every developer runs into. Then we'll get into the brilliant solution, thinking in hierarchies. We'll see how characters travel between these different states, how this brain talks to the rest of the game world, and finally, some real-world advice on how these things are actually built and debugged. All right, let's dive right in. It all starts with one really fundamental challenge that every game has to solve. I mean, think about it for a second. At any given moment, your character has a ton of options. 1 second they're standing still, the next they're sprinting, then they're jumping, then they're taking a hit, all within a fraction of a second. The real challenge is, how do you manage all of those possibilities without your code turning into a complete and utter mess? You know, you look at a list of actions like this, and it seems simple enough. But the complexity is in the connections. You can't reload while you're climbing, right? You can probably attack while you're walking, but not while you're using a health potion. And here's the kicker. You need to be able to take damage from any of these states at any time. If you try to draw a line from every action to every other possible action, well, you get a big problem. And that problem has a name: spaghetti code. For a long time, the standard solution was something called a finite state machine, an FSM. It's a classic idea from computer science, but as games got bigger and more ambitious, these FSMs just got tangled into this unmanageable web of arrows and transitions. It's an absolute nightmare to debug. And if you want to add a new ability, forget about it. So, how do we fix this tangled mess? Well, this brings us to the core idea that pretty much changed everything for game AI. What if, instead of a flat to-do list, we organized all these actions like they were a family tree? And this quote right here, this is the aha moment. This is the whole secret. With this new way of thinking, your character isn't just in one state. They're in their most specific state, which is the leaf, and they are also in all of its parent states at the exact same time. Basically, states are nested inside of other states. It's just like how you organize files on your computer. You'd never just dump thousands of files onto your desktop, would you? No way. You make folders, and folders inside those folders. It brings an incredible amount of organization. And as we're about to see, it lets us do some really clever things with our logic. Let's make this a bit more concrete. So if your character is walking, that walk state is what we call a leaf state. But because it's inside the locomotion state, your character is also in locomotion. And locomotion is inside movement, so they're also in the movement state. It just makes perfect logical sense and cleans things up so much. Okay, so we've got the structure. We see how it's organized. But so what? Why is this so much more powerful? Well, it all comes down to how a character actually moves between these states. It's a total game changer. With a hierarchy, you get two massive wins. First, shared logic. Think about it. Any code you put in that parent movement state, like, say, code to check for walls, will automatically apply to walking, running, and idling. You write it once, and it just works for all the children. And second, you get what I call smart transitions, which makes the whole thing run way more efficiently. Let's do a quick comparison. In an old, simple FSM, you just jump from one state bubble to the next. But in a hierarchical FSM, the machine is actually intelligent. It looks for the closest shared relative between where you are and where you're going. It only exits the states it absolutely has to and only enters the new ones. It doesn't have to rebuild the whole chain every single time, which is not just cleaner, it's way, way faster. So this HFSM is pretty brilliant, right? But it's just the brain. A brain is kind of useless if it can't talk to the body. In this case, the animation system, the audio system, you name it. It needs to communicate. So in most modern game engines, this is handled by a really popular design called an Entity Component System, or ECS. The easiest way to think about it is like this. Your character is just a blank container, an entity, and then you just plug in different components like Lego bricks. Here's a health component, here's an inventory component, and yep, here's our HFSM brain component. So how do all these Lego bricks talk to each other? Well, when the state machine changes what it's doing, it doesn't shout orders. Instead, it just sends out a little broadcast, kind of like a system-wide memo. It says, hey everyone, just so you know, this character just went from the run state to the jump era state. And other systems are listening. The animation system hears that and goes, got it, playing the jump animation. Now, here is the golden rule. This is a trap that gets so many new developers. The state machine doesn't think on its own. It's not alive. Every single frame of the game, we're talking 60 times a second, the game engine has to go around and tell every state machine, hey, time to think. They call this a tick. If you forget to do that, your characters will just stand there frozen forever. All right, so this all sounds great in theory, but how do developers actually put one of these things together without losing their minds? And more importantly, what do you do when your character suddenly decides to start walking through walls? Let's get practical. To stop you from making mistakes, most engines give you what's called a builder. It's a much safer step-by-step way to create your machine. Instead of trying to connect all the wires yourself, you basically just fill out a form. You define the states, who their parents are, what code should run when you enter or update a state, and so on. Then you just hit build, and it constructs the whole thing for you, error-free. And here's a final pro tip that will save you so many headaches. Just name your states well. It sounds so simple, right? But using a clear, consistent naming convention like this example, jump, air, fall, land, makes your debug logs 1,000 times easier to read. And even better, you can often name your animations the exact same thing, and the engine can automatically hook up the state to the animation. It's beautiful. So that brings us to one last thought. We've spent this time talking about how these hierarchical brains can power complex character behavior, but their use really doesn't stop there. What about managing a quest with tons of branching paths, or a weather system that needs to transition smoothly from sunny to cloudy to a full-on thunderstorm? The principles are exactly the same. The possibilities are pretty much endless.